In today's lecture, we are going to understand, study about one very basic concept called references. We have used it a lot in assignment 2. If you think about it, all the vectors that we were using, we were passing it by reference. But I hope you would have found out what passing by reference means. But if you haven't, initial at least 10 or maximum 15 minutes of this class, you will be going through what we mean by references in C++. Okay. And these are the other topics that we are going to discuss. We are going to discuss what it means to pass by value or pass by reference to functions. And we are going to start object-oriented programming in C++ after that. Okay. And references in C++. So for whatever code that we are writing there, let's assume the output is going to be printed here. Okay. So that is an integer variable called n with the initial value of 10. Okay. And this particular line, just means that we are creating a reference variable. Listen to me carefully because this is very important and very basic. So we are creating a reference variable called Rn, reference to the variable n. And how do we say that this is a special type of variable, or this is not a normal variable, but this is a reference? This is using this particular symbol. Okay, this using this ampersand symbol, we just say that okay, this is actually a reference. Rn is a reference to another variable called n. Okay, simple until now, it's okay. Can someone you need not raise your hands, but can you just shout out what may be the output of this particular line? We are trying to print n and the reference variable Rn. 10 n? Yeah. So the answer, one of the answers is 10 for the value of n, and address of wherever in memory this variable n is stored would be printed for Rn. How many of you think that's correct? Okay. Any other answers? Yeah.
10, 10.
Good. Actually, that was wrong, and the answer is 10, 10. This is the actual output. Okay. So what this means? Okay. So what this means? Let's see. I'm not going to explain that right now, but let's proceed through this. Now we are changing the value of n to 20. Okay. From 10, now it's became 20. Now, can you tell me what is going to be printed? What is the value of n and Rn? N and the reference, yeah?
Well, I should have. I'm not confident in my answers.
No, that's fine, yeah. You need not be confident about it.
I'd say 2020.
2020. Huh? Any other answers? Yes, it's 2020. Great. And again, what happens if I say Rn is equal to 30? What is going to be the output of this particular line? Anyone? Yeah?
2030.
Pardon?
2030.
2030? No, actually it's 3030. Okay? So, from whatever code or this simple piece of code that we saw here, okay, let's try to understand what these references even mean. Okay? If we change n, both n and Rn are changing. If we change Rn, again both n and Rn are changing. Okay? So what does it even mean? Why do we even have this reference variable? That is the question right now. Okay? So for that question, let's see, for the same code, what happens in computer's memory. Okay? When this particular line is executed in n is equal to 10, we have a variable called n with some memory allocated for it, and that particular variable's value is 10. Okay? And then now we have a reference, the same reference to n, Rn, and we assign it the variable n. All this means, okay, all this particular line of code, the second line of code means is, this Rn is like an alias to the variable n. It's just like alias, another name. Yeah.
So when you say address Rn?
No, that's not address.
Okay.
So that ampersand sign is not address. If you are coming from a C background, okay, if you are coming from a C background, or if you already know C programming language, you have to forget whatever you learned till now, and then not forget, you will also use that because C++ is based on top of C, but here this ampersand sign on the left hand side, because this left hand side, this is like a, so in C, if you use that ampersand sign on the right hand side, it means it's like address of that particular variable. Okay, so here see that the ampersand sign is on the left hand side of the expression. So this is on the left hand side of the expression, and so this ampersand sign in this second line of code just means that Rn is a reference variable to another variable called n. Okay, and what does a reference variable mean? A reference variable in this particular context is just like in C++ is just like an alias to that variable, just another name, alias to that variable n. So now if I change n is equal to 20, then it's going to change the value of n. And then if I change Rn is equal to, if we're going to change Rn, then it's going to change the same thing. So remember that there is no separate memory allocated for this variable Rn. Okay, there is no separate memory that is allocated for variable Rn. It is like we are just saying from the second line of code there, we are just saying Rn is an alias to the variable n. Okay, after that particular line, we can refer to that same memory location or this particular variable n using either n or Rn.
So you're just creating a copy of that.
Not even a copy. We are just attaching a name to it. That's it. Another name to
So
it.
yeah.
So we are not creating a separate copy. We are just attaching or assigning a new name to it along with the old name that it had. This particular variable had a name previously as n. Now we are assigning one more name to that same variable. You can think of it like that. That now you can refer to the same variable with the name Rn2.
What's the point of this app?
Yeah.
Using that we have different variables.
Yeah, that's a very good question. So this particular piece of code is like the dumbest piece of code that you can see, because you can. The obvious question is, why do you even want to like give this two names to the same variable? Because you'll get so confused with just one variable name. We easily get confused in our code so much, right? But this may confuse us even a lot. Why do we even do this? We'll look at it in the next slides. Okay. Any other questions about just understanding the syntax of reference variables in C++? So forget that nothing is related to address here. Coming from C background, okay. This is like this is just saying Rn is another name for the variable n. That's it. Okay. So with this, then we'll proceed. So Rn is an alias to n. That's it. Okay. This is what this particular line of code means. Now that is what references mean. So now to answer your question, we will be like studying that when we are passing by reference. Okay. So now let's understand what do we mean by passing by value in C++. If we are passing any variable to another function, the default mechanism that the language uses for passing the variables is passed by value. Let's see an example of what this means. Okay, passing by value. Let's take a few minutes to go through this like 3 lines of code here. So all we have here is like a function called dblvec. It just stands for double the vector, okay? And then it takes in a vector. It takes in a vector of integers as input, and we just have a name for the particular argument called vf, okay, here. And then we have a for loop which starts from the vf, the first element in the vf, which is vf.begin with this iterator, and then it goes to the end iterator, and then for each and everything we increment one element. And then can someone tell me what this function is doing? There's so many clues there, and the function is there.
Doubling each element in the vector.
Yes, all this function does is just doubling each element in the vector. By that, mean like if the vector has elements 1, 2, 3, we are trying to make the elements of the vector 2, 4, and 6. That's all this is trying to do. And so I'll try to explain what is happening here. So to access the element inside the vector, we have to dereference the iterator. If you remember, while printing, if you want to print the elements of the vector, you say star it, right? In a very similar way. This just means we are accessing that element inside that wherever it is pointing to, and then this assignment, this is like all you would have known. This star equal to means like star it is equal to star it multiplied by 2. Okay, so we are saying whatever element is there, take that element on the right hand side, multiply it by 2, and then assign it to the same place, okay, to the same location. That's all this does. Takes an element, multiplies it by 2, and rewrites it in the same position. Okay, so is everyone clear with this code? And then assume we have the main function here. In the main, we have a std vector of integer v main. V main just stands for the vector that is inside the main function. and assume we have some code for filling the vector using pushbacks, okay? And then we call this particular function here, we call that dbl vec, double the vector, is ending in this v main, okay? Now what happens here is, if this is the vector that is here, like for example, if this is the vector that we have in main, when this particular function is called now, okay, first thing the compiler would do is go to that particular function dbl vector's definition and see what is, how is this variable taken, okay, as input. This variable now has no special symbols around it. It just says vf is a vector of integers. So at this time, okay, this variable, this vector v main, okay, from the main function is passed by value to the function dbl vector or the double vector, okay. So what this means, passing by value, is the entire contents of this particular vector is being copied, okay. A separate copy of this particular vector is made specially for the function dbl vector. So after this particular line of code is called, okay, when this is called, and assume now we are here, okay, in this function, a copy is made, and that copy is given a name vf, okay. And when we execute this for loop now, okay, this copy becomes 246. The copy of this vector becomes 246. And then when you actually, after this particular line of code, when you return back to main, okay, when you return back to main, when this line is complete, when this line has completed execution, when you return back to main, this particular function has gone out of scope, okay. This particular function, double vector, has gone out of scope, and so has the vector vf. Once this function completes, we will not be able to access this vector vf because this vector vf was a local variable to this particular function dbl vector, okay. And once this is done, we have lost the double values, and now when we come back to the main function, we will only have the unmodified vector 1, 2, 3. So this is what happens when you pass a vector by value. This does not only apply for vector. We can even pass like simple variables like integer variables, okay? We can even do the same thing with integer variables. So in C++, arguments are passed by value, by default, okay? By default, arguments are passed by value.
So is that occurring because it's a primitive type, or is that just for anything you pass into the parameters?
So anything. So the integer is a primitive type, but vector is not a primitive type, right? Even for a vector, we actually make a complete copy of the vector and then only modify the copy. So this was the copy that was made, then we modify the copy, and when we come back to main, the left hand side is completely gone, only you have the right hand side. Any questions about this? So clearly, when we are writing a function where we want to modify this vector that we have created in main, we cannot do it the default way. By default way, we mean we cannot pass the argument, which is the vector, by value or any other variable. It can be any other variable, okay? We cannot pass it by value to the function. When you pass it by value, a separate copy will be created of that particular vector inside this particular function that we are calling, and only whatever modifications that we are making here will only apply to this particular vector. Does it make sense? And so, if you think about the functions that we had in A2, almost every function used the same vector that was created in the main function, okay? So how can we achieve something like that? Or in the same way, how can we actually double the same vector? We don't want to double another vector, but we want to just double the same vector. How can we do that? Is the mechanism called passing by reference, okay? So in passing by reference, now actually I think I did not update this, okay? This should be passing by reference, okay? This is like a typo in the slide, okay? This is passing by reference, and in passing by reference, this piece of code is exactly the same. Just this single ampersand sign that has been added here is the only different information that we are telling the compiler. And at this particular position, all we are telling the compiler is, okay, now I'm going to do the same thing, like double the vector, but this vector that is being passed to me as an argument is not passed by value. So please don't create a separate copy of the vector locally for my own purposes, but can you just rename the vector that is being passed from main, okay, to be this. So let's see, I think that was too much. Yeah. So that's main here, okay? And the same, all this code here remains the same. The way we call this function also remains the same. We don't have any syntax changes here, okay? But now we have the v main here, 1, 2, 3, and when this dvl vector, the double vector is being called right now, now what happens is, a copy of the vector will not be created because we have this special symbol called ampersand. It says that vf is just a reference variable, and it will be something like this. Let's assume there is some variable called vf created inside this particular vector, but all it does is it just refers to the same vector v main. This is all is happening inside.
So when I was doing some catching exceptions, and it recommended that I put an ampersand on the right side of one of the variable names.
I'm not sure. We should maybe you can look at the code later to see, because I don't exactly know what's the problem. Yeah.
Do you need the star in front of the it for it to work?
Do we need what?
The star in front of the IT for it to work?
Yeah. So this star symbol for the IT just means that IT is an iterator to some particular element, okay? But if you want to access that element itself, you have to say star IT. If you think about just printing that element also, you will just say cout star IT. Okay? Because IT is an iterator to the particular element. If you want to go to that element itself, it is star IT. It's called dereferencing. The dereferencing the iterator to actually obtain the element in this particular case. So the only piece of information or the piece of code that changed in both pass by value and pass by reference is just this ampersand sign. Okay, it's just this ampersand sign, but internally we have avoided a whole copy of the vector. So this is just a 3-element vector, but think of in real world vectors would be like millions of elements. In that particular case, if you pass by value, just for the function call, it may take like 10 seconds to complete, because it's going to like create an entire copy of the vector to be processed by that particular function. So usually whenever we create like manipulate vectors, most of the time it will be just one vector, and we will be like using reference variables to pass it to functions, so that at this point also it's the same definition. Now vf is just an alias for vmain. Okay, now does it make sense? Why do we need aliases? Now this is the only reason or the main motivation for your references in C++. So you don't completely copy like containers or big data structures that you have, but you just pass them by references, so that we are saying now vf is just a alias or like another name for the original vector called vmain, and so hereafter inside this particular function, whatever you do on vf, okay, is very similar to doing that same operation on vmain, because both vf and vmain is just the same name, is just different names for the same vector. This vector 1, 2, 3. Are you guys clear about references? Any other questions? Okay. And this is like, this just says this is alias to this vmain. That's it. Okay. And after this, now at this time we were here, and after this loop gets executed, now whatever operation is done on vf will be reflected in vmain. If you see vmain now, it gets changed to 2, 4 and 6. Okay, and so we have just manipulated the original vector instead of creating a whole new copy unnecessarily here. Not only unnecessarily, even for correctness. If you want this vector to change in main, then this is how you should do it. Okay. Please try to understand references in like much more detail. This is like a very high level usage of references, because understanding references would really help you to understand so many other things in C++. Even in assignment 3, you'll be like using references like a little bit in the classes that we are going to create. Okay. And yeah. And the last thing that we're going to discuss today is classes in C++. So we are not going to write any code for references. I hope that you can just go and replicate the same thing, or I can post some code online in our poster page. But the code that we are going to write today is mainly about how to create classes in C++. And the assumption that I have of all the students in this class is like everyone would have taken at least one object-oriented programming language before, like Java or Python, or you will be familiar with what object-oriented programming means. So in this class, with the limited time that we are having, I will not be trying to motivate why we need classes or why we need like object-oriented programming and stuff like that. But if you are not coming from object-oriented programming background, please come and meet with us during office hours so that we can get you up to speed of why do we need all these things. So is that a valid assumption that I can make? Okay, so we can just go. The class from now on till the end of the class, it's going to be how do we implement classes, okay, in C++. Okay, from now, try to like bring your the knowledge that you had in Java of what is a class and everything. Okay. So till now we were using this like a little motivation. Till now we were using containers like vector and maps and sets and stuff like that. But assume now we want to create a user-defined data type. By user-defined data type, let's assume we want to. I like this example a lot, and I think I will be using this example for most of the time we are discussing about object-oriented programming, which is about a student class. Okay. So let's think that we want to create a class for a student, like having all the details of that particular student. It can be anything that you want, but let's start with very simple examples. Okay. So at this point, I'm going to create a C++ class. Okay. Till now, this is the first class that we are creating. Till now, we are writing all the things inside main.cpp, and so I'm creating a class for student. Okay. So now, in C++, the first major difference is whenever you create a class, there will be two files that will be created. Okay, you have to, if you are writing it in Vim, you have to create your class in two separate files. The first file is called a HPP file, okay, which just stands for the header file. The PP stands for C++. That's CPP, HPP. That's just like matching of those two things. Usually people may follow patterns like .cpp and .h, okay, and it can be anything, but usually in this course and in most of the places that I have worked in C++, we follow this convention of having .cpp for the implementation files. We'll also go into the details of what implementation files mean, and .hpp for the header files. And whenever you have a header file, these three lines of code are called include guard. I will not be going through the include guard right now, these two lines and this line, but just understand that these three lines just tries to avoid people to include your header file multiple times. If someone in main.cpp tries to hash include student.hpp somewhere and somewhere else, again they do it multiple times, okay? If they do that include multiple times, this include guard will prevent them from doing so. Okay, that's the high level need of why we need include guards, but there are much more details to it to understand each and every line. I will not be going through this because it's not needed for this class. And yeah, with this now we have a class student, okay, and this is how the classes in C++ ends with a semicolon, okay. And let's go and see the CPP file. CPP file, we have nothing, but we just have included the header. This has been already created by CYN, but yeah, this is the normal template that you will have. So I'm saying in CPP file, I'm saying hash include student.hpp, okay? But in student.hpp, we don't have anything as of now. So for creating a student, again, now we are going to create the data members, okay? You may use whatever term you want, but at least for the purposes of this class, I will be using data members. You can use data members, data fields, or some other things that you're using, but you understand the idea, right? We are going to create data members for this particular class, and all data members should be private, okay, in C++. And so when you have, it need not be private, but usually when we are creating object-oriented programming, like a class, you will not do access to your data members, and so everything should be private. And so I'm going to write some data members here. So for a student, we know that we may have like a name. Let's have like a name for a student. So name is the std string, and we just say name, okay. And then let's have, as of now, we can have just like a year of birth, okay? We just have a name and a year of birth. And immediately, we know that whenever we have like private data members, we will have like public accessor methods, okay, or public data functions, or like the instance methods that we are going to write now to access these things. So it is going to come under the public scope, okay, and in the public scope, since we have a variable called name, we are going to have like a getter method for that particular name and a setter method for that particular name. So it's going to be get name, okay, writing a getter method get name, and since it is a getter method, we need not give it any argument, but it just returns, it is going to return you a string. Okay, and then we are going to write a set name, okay. This is like a setter method for name, and since it is setting the name of this particular student that we will be creating, so we are going to pass in a string here. A string, let's say name, okay, and this does not return anything, it's just a void method. And in a similar way, we will be having get year of birth, which does not take in any input, but it returns a string. Okay, and we are going to have like set year of birth, which takes in an integer, let's say year as input, and then we don't return anything. Okay. So the first major difference that you would have noticed here is like in Java, we would have returned like, let's say, private string name, private in year of birth, private string get name. Do you remember? For every data member or for every method, you would be prefixing the private or the public keyword before that. But here, what we will be doing here is like just say all these things that are returned here are private, okay, and all these things that are returned here are public. That's it. Okay, so you just use those keywords only once inside your class. And now, in your HPP file, okay, the instance methods, okay, the methods that you have for this particular class, the instance methods, these are, we are not defining the methods, but we are just only declaring these methods. We are just telling that these are the methods that will come inside this particular class called student, okay. But in Java, we only have like a student.java file, and we will write the data members there, and we also will write the implementation of the methods inside the class itself. But here in C++, it's not the case, because here we are trying to do separate two things. The HPP file only has the interface of the class. By interface, here we mean if some client, let's say in our case main.cpp, someone else is going to write, let's assume someone else is going to write main.cpp, and the person who is going to write main.cpp is our client, okay. So till now we were the clients of like vector class or unordered set or unordered map. We were the clients of those classes, okay. But now, right now, we are going to become clients of this class. So in this particular context, we are both the implementers and the clients of the same class. Okay, we are trying to implement it here. So assume when we are using this student class in main.cpp, main.cpp will only include, it will say #include student.hpp. All it needs to know is what are the different methods that this class offers, okay? These 4 methods, and that particular information is just called the interface of that particular class. How do we even like interact with this particular class, okay? This is how you interact with this particular class. And so in HPP file, you will only have the interface. So the implementation of all these methods, we will push it to the .cpp files, which is called the implementation files, okay? And that is what we have here, student.cpp, and let's go and start defining these methods one by one. So when you want to like define a method here, okay, this syntax may be slightly different for you, coming from a Java background. Let's see. So let's say like we want to say get name, okay. If you want to define a method called get name, we're saying we are going to define a method called get name. It's going to return a string for us, okay. And once we do this. Once we do, okay, get name is going to return a string, we can define this method here. But the syntax of C++, okay, tells us that if this is an instance method, if get name is an instance method of the particular class called student, what we have to do here is we have to prefix the name of the class before this method. So we have to say this particular class is inside the student, this particular method is inside the student class. And this operator that we have here, the double colon operator that we have here, okay, this double colon operator that we have here is called the scope resolution operator in C++. It's called the scope resolution operator. All it means is we are going to this particular line now means we are going to define a method called getName, and this getName method is inside the class called student. That's it. Okay, that's all it does. But this is how you define classes, yeah, different methods.
Why do you do that if it's already in the student file?
Yeah, that's a very good question. So why do we even do this, okay? Why do we even do like this name of the class and then the scope resolution operator when we are already inside student.cpp? The reason why do we need to do this, if you remember in the first class we told C++ is not purely object oriented. By that we mean you always need not write class even to print something. Okay, till now we were not even writing any classes, right? We are only using the main function and we are only using other methods directly. We did not write any class. So this, with the same trend, in any file like even like student.cpp, we can have a method, any method like function, just like a function. We can have like a function that does not belong to that class, but is just a method here. It can be like something that you want to print. This is also valid code inside this file. So it means.
What's the difference between those two?
So the difference between these two is the getName. The getName is the instance method of the particular class called student.
Okay.
But here we are defining a method, some helper method for ourselves, which need not be an instance method inside the class that we have, which is the student class, but we may just use it for some other purposes inside this file. So this does not even belong to that particular class. It is just present inside this file, but it does not, this function fn does not even belong to that particular class. Does this make sense? That's a very good question, and this is the reason why we are having that scope resolution operator, even though we are writing code inside student.cpp. Do this, and then in the same way, so now this particular thing should return the student's name, right? Just returns the name. And then we have say student get year of birth, sorry, or like let's say let's set the name first, or like get year of birth. Let's just define the getters first, okay? The get year of birth should just return year of birth, okay? And in a similar way, giving student, these are like shortcuts. This is type student and the scope resolution operator. It shows me what is the method that I want to define. By say set year of birth, okay? Then we can just say year of birth is equal to year, okay? And the last method that we want to define is like set name, right? Set name. So in the set year of birth, all we have done here is like year is the integer argument that is coming to this particular instance method. We are assigning whatever year is coming as the year of this particular student, and YOB, the year of birth, is the data member that we gave there inside the student.hpp, okay? But here, since this argument here and this YOB are of different names, we have no issues. We can just do it like this, okay? YOB is equal to year. But in the next function that we have here, the set name, if you remember, the private data member's name is also name, and the input argument that is coming here is also named as name. In this particular, when this is a scenario, what will you do in Java? Yeah, very good. So we will just say this dot name is equal to name, right? To refer to this particular thing. Say this dot name is equal to name. But here in C++, if you just do this dot name is equal to name, this will not work, okay? Because we will be covering this thing later, but this in C++ is a pointer, okay? This is a pointer. So we have not covered pointers, we will be covering it, but as of now, let's just think or like you may like just believe me, okay, that this in C++ will not be using this dot, but instead we will be using this arrow. Okay, this dot name is equal to name. Okay, because this is a pointer in C++, we will be covering pointers later. Don't worry if you don't understand what a pointer is, but as of now, the idea is the same. The idea is very similar to Java. Like you say this dot name is equal to name. But in most of the current C++ code, what I observed is like people don't use this pointer, but the most of the code is like, okay, I'm just commenting this out. I think this is more like for clarity, I'm not very sure, but all they say is, okay, student, okay, this is another way of doing it, student name. Since you have the scope resolution operator, now you can attach the scope resolution operator to the private data field called name, and you can just say the name, which is the private data field inside the student class, is assigned the value of this variable called name. Does this make sense? This is the thing that you will be using for most of the time, or like in most of the code you will be seeing this. Does this line make sense? Instead of using this is also a valid way to use it, but instead of using this, what we are using here is like using the scope resolution operator. We are saying I am assigning the value of the string called name, which is on the right hand side, to the actual private data field called name, which is inside the student class. We are using the scope resolution operator to achieve this. Any questions about this? Okay. So now with all these things set, okay, now we almost have a full-fledged class. Let's go and see if we can create an object of this particular class. Okay. Okay. In main, now think we are switching our roles from an implementer of that particular class to a client of that particular class. By being a client, we will be creating an object of that particular class. Let's say student. Okay. So if you see here, when I type this was included here. Okay, the hash includes student.hpp was included here. So whenever you want to use a user-defined class, you have to only include the header file. You should not include the source file, because source file has all the details of the implementations. But whenever you use some functions from your class, your main does not need to know all those things. Okay, all those things are needed only at the later process in compilation. That's called like linking, only during that time. And during that time, the implementation files, so the .cpp files will be brought and will be like attached with the executable. These are like, if you have taken 354, whatever, the last two statements would have made sense, but else don't worry. Okay. So now here you have like student. Okay. Here we are going to create a new student. Let's say S1. Okay, student S1. And if you think about it, here, now if we had created a vector variable here, let's see how would we create a vector, okay? A vector of, you would have given integers, n, let's say v, yeah, something like this, right? So in a similar way, when you want to create a student, you just say student space S1, okay? That in the angle brackets and integer, that thing is not needed when you're creating object of your own type, but we will be learning about that when we are going into templates. Okay. So now when you want to create a student, this is how you just create it. So I'm just deleting this line. I just wrote this to give a comparison between these two things. Okay. Instead of vector, now we have defined our own class called student, and we have S1 now. So now we can use S1 and say dot set name. Let's go Varun's name, okay? Like Varun. And then S1 dot set year of birth. So if we have like these two things set, now we can try to print the student's name using cout, okay? So even this particular operator that we are using here is again the scope resolution operator, but in this context it does not, std is not a class, but std is a namespace. We are saying we are using the cout that is inside the std namespace. Okay, scope resolution operator is used in multiple contexts. Okay, and so here we are saying just s1 dot get name and have a comma in between, and by saying s1 dot get year of birth. TD inline. Now we run this. We see this here, Varun, 1992. So we have successfully created our first object of this particular class called student. Okay. First we defined the HPP file, which has only the interface. By interface we mean all these public functions that we have here. Okay. Only the public functions. We have defined the interface here, and we have defined and we have like written implementation in .cpp file, and in main.cpp we have created an object. So in line 9 we are saying we are creating an object of type student, and the object's name is S1, and we are assigning a particular name for that particular object and the year of birth for that particular object, and we are trying to print that particular thing. If we think about it right now, we can easily predict that when we are using this, we may want to, like, if we are creating multiple objects, we may be using this print statement or printing the students more often. So let's go and create a method for printing the student, okay? So here, again, go to the public interface, write a method called print. Let's say print student, okay? Just write a method called print student. It's going to print the details of the student, and it's a void method. And here in CPP file, you can just define that particular method here. Say student, print student, okay? And whatever line you had here, you can just bring it here. The printing line, now we are creating an instance method with the printing line, so that is going to be easy for us. So here instead of S1, it can be just get name, because we are inside that class itself right now. So it understands which is the object that we are calling these methods on. This should be fine. Just get name, comma, get year of birth. And in the main.cpp, instead of writing the print statements here, the client now can easily call s1.printStudent. If you see here, we have the same output now, okay? And now at this point, if you think about it, what will happen, okay? Can someone tell me what will happen if by mistake we print the student even before we setting any of the details of the student? So I'm trying to create a student object, and immediately I'm trying to print the student's details. Can someone tell me what may happen here?
We'll just pull whatever memory.
What?
We'll just pull whatever memory, the location is variable.
Just whatever is there, you mean? Okay. So the answer was like maybe whatever contents is there in that memory location, we'll just try to print that. Let's see. So do you see this? So the reason, okay, let's see. So just note this number, okay? It's some number, some random number that's being printed here. If you run it another time, will you see this number change? It ended in 2, now it ended in 6, okay? This is the year of birth of the student. Maybe it was born like so long ago, okay? So long after. If you can see here, the number keeps on changing, okay? So the reason here is, okay, the reason why this is happening is, in your student class, int is a primitive type. For primitive types, if you don't initialize it explicitly, okay, like a year of birth is some value, then it will take some random value, okay, whatever was there in the memory location previously. So this year of birth will have a memory location for that particular variable. But since we have not initialized it, it will take some garbage value that was there in the memory location, which was used by the previous program that was running there or something like that. And then it will print just that garbage value for you, okay? But if you notice, the name, okay, the variable name or the data member name was always printed as empty strings. If you notice it there was nothing printed here. You see this here? Before the comma, there was nothing printed here. The reason why this is happening is std string is a container, okay? It's a container written in the standard library. And so for containers, whenever you just even say std string name is by default initialized to empty string. So the creator of the container does that for us, okay? In a similar way, if we want to, whenever you want to create a student object, if we want to initialize a student object to something, we want to have a special member function. Okay, a special member function. What's the name of the special member function? A constructor. That's it. So here you just write a constructor. Say if someone calls just student without just this constructor, this again I'm just defining, I'm just saying this is the interface, okay? It does not have any return type, okay? And then you go here and you define your constructor here. Usually I prefer writing constructor as the first thing here. And yeah. So now someone, when they call student, now we can say always the name. Okay, we need not worry about the name because the name is always will be empty string. Or you can, if you want, you can say always if someone no name. Okay, something like you can give the default name as no name, and you can just say the year of birth is by default 0 or something like this. Okay, and now when you have this constructor, here we don't do any change. Okay, so now when we create the object called S1. the constructor that we just wrote now is called the default constructor. The default constructor gets invoked, and when the default constructor gets invoked, even before we set the things, when we print the student, the name should be no name and the year of birth should be 0. Okay, we see this. You see this here? We did not make any changes to Mint or CPP, but all we did was we added a constructor, a default constructor, which means that okay, whenever someone is creating a student, always if they don't specify any name using the set name methods, always have it as no name and 0. But after these two lines, after this print statement, we are actually setting the names. So here, let's go and try to print the same student details after these are being set. Okay. When after these are being set, the student details becomes Varun and the year of birth is 1992. We are printing the details for the same student here 2 times. First, we did not initialize the data fields, name and year of birth. Second time, we have actually initialized it. Okay. Yes, I think how many of you understood whatever was going on here? Yeah. Okay, great. I think this is the level we will be dealing with object-oriented programming, because I will definitely assume that you know object-oriented programming, because this course is like C++ for Java programmers. Okay. Guys, thank you, and assignment will be released soon. The next assignment you may work in pairs optionally. Yeah.
Alright, so what's that?
Thank you, and see you next week.